Hey, we are talking about inverse trig functions today. So we're going to just go ahead and review a little bit. If we're given an angle, and we usually call a missing angle theta, so go ahead and fill that in, okay? Missing angle is theta. We can find 6 trig functions, and that's sine theta, cosine theta, tangent theta, cosecant theta, secant theta, and cotangent theta. If you cannot kind of hear the names of those abbreviations in your head, go ahead and write those out, okay? Remember, we would use SOHCAHTOA to solve this, and we have those 3 musketeers of trigonometry, right, that we use to solve a triangle, and that we can use to find these 6 trig functions. So what if we don't know? So again, this is something you need to fill in. What if we don't know the angle theta? So then you would have to use an inverse trig function. And here's what this is. Basically, it's the opposite of a trig function. And instead of finding the trig ratio, we're looking for theta. So the inverse of sine theta is this notation of inverse sine. Okay, so there's our inverse of sine. Theta is inverse sine. This notation right here, it looks like to the power of -1, but we actually say that that's inverse sine. The inverse of cosine is inverse cosine, and the inverse of tangent is, of course, inverse tangent. So we have, go ahead and take your highlighters if you need to, and really color this in, make sure it's really, really, really in your brain. So what we mean by this is instead of finding the value of a ratio of the trigonometric function of an angle, we would use an inverse to find the angle instead of the value of the angle. So if sine 60 is √3/2, then we say the angle, so again, we're finding the angle where sine is equal to √3/2 is 60. So again, the inverse function finds the angle. Okay, so the inverse finds the angle. Or we could say inverse sine of √3/2 is 60 degrees. So in your book, you've got this this figure here, and this is really important. So the inverse of sine is only valid between quadrants 1, remember this is quadrant 1, and then this down here is quadrant 4. So the inverse sine is going to be somewhere between 90 degrees, so up here is like 90 degrees, and then here's 0, and then we can go all the way down to -90 degrees. So the inverse function of sine exists for theta is between 90 and -90. The inverse cosine of a function exists between 0 and positive 180 degrees. So this is in quadrants 1 and 2, where this is 0 degrees and this is 180 degrees, or 0 radians to pi radians. And then lastly, the inverse tangent is valid between 90 and -90 degrees. And just like inverse sine, it's in the first and the fourth quadrant. Okay, so in order to do these and find these values, remember that we have this common angles chart where we know the common angles are 30 degrees, 45 degrees, and 60 degrees. Go ahead and fill this in. And remember, 30 degrees is the same as pi over 6 radians. 45 degrees is the same as pi over 4 radians. And 60 degrees is the same as pi over 3 radians. And we can look for the sine, cosine, and then we'll find the tangent later. But remember, it's as easy as, to fill this in with me, okay? It's as easy as 1, 2, 3, 3, 2, 1, all over 2, and then root, 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 root. And then that's how we find sine and cosine. Tangent, remember, is the value of sine divided by cosine. So 1/2 divided by the root of 3 over 2 is root of 3 over 3. The root of 2, or sine of 45, divided by the cosine of 45 is root of 2 over 2 divided by itself, which is just 1. And then to find the tangent of 60 degrees, we take the sine of 60 divided by the cosine of 60. So root 3 over 2 divided by 1/2 just gives me the root of 3. So we're going to use this box. You want to be able to reproduce this anytime you're going to find values of theta using sine, cosine, or tangent, and inverse values. So we use this all the time. You need to be able to reproduce that quickly and easily. Okay, so we're going to use that this box to help us find our evaluation of radians and degrees. So we're going to evaluate the expression in radians and degrees. So if it says find the inverse of root of 3 over 2, what we're really saying is what theta does the cosine theta equal the root 3 over 2. So we want to know what goes with cosine where it equals the root of 3 over 2. So we see here and here, so it goes to this angle. So we would say theta equals either 30 degrees or pi over 6. Okay, so let's go ahead and clear that. So for the next one, we want to know the inverse sine of 1/2. What we're really saying is what value of theta does sine theta equal 1/2. So what we're really looking for here is where does sine equal 1/2? So here's sine and here's 1/2. We see that's right here. We see it where theta equals also 30 degrees, comma 1 pi over 6. Okay, and then lastly, for tangent, inverse tangent of negative root 3, we know, okay, what value of theta does tangent theta equal a negative root 3? So a couple things we need to know here. We need to know tangent equals the root of 3, and we see that's up here, okay? So we know it's at pi over 3 and 60 degrees, but remember, this negative kind of tips us off. So remember that inverse tangent, if we look up here, whoops, right here, we know it's either in quadrants 1 or 4, and because it's negative, we know that tangent has to be negative only in the third quadrant, the fourth quadrant, because in the fourth quadrant, only the cosine is positive. So tangent would be positive in the first quadrant here. That means tangent has to be negative in the fourth quadrant. So we need to know where is theta in the fourth quadrant here, a pi over 3 or 60 degrees. So I know if this is 360 degrees right here, 60 below that would be 300 degrees, or instead of radians of 2 pi, this would be 5 pi over 3. And that's where theta is when tangent is negative root 3. All right, let's go to the next one. It says solve sine theta equals negative 5 over 8, where theta is between 180 and 270. So this tells us where it is. So this is 180 degrees here. Here's 270. So we know theta is somewhere in the third quadrant here, okay? So we want to know where is sine theta equal to negative 5/8. So if I wanted to draw theta, it'd be somewhere inside here. And we know it's going to equal to negative 5 over 8. Well, here's the deal. If I write this out, the way I can get theta by itself is by taking the inverse of sine on that side. So inverse sine of sine cancels it out, which means I'm going to take the inverse sine of this side as well. So I know theta equals the inverse sine of negative 5 over 8. So I end up with, use your calculator, and we end up with approximately, the calculator tells me, negative 38.7 degrees. So remember, now wait a minute, how could this be a negative 38.7 degrees? So keep in mind that sine, again, has to be in this, has to be a value of negative. We know sine is negative in the third quadrant. So a 38.7 degree angle in the third quadrant here means from this 180, it goes down 38.7 degrees. So we're going to go 180 plus the 38.7, and we end up with 218.7 degrees is that angle if it was in standard position. So this is right here, 218 degrees, 0.7. And then finally, what do you do if you've got a triangle and you're finding the measure of theta? So I don't know the angle, but I know two of the sides. So just like we were solving triangles before, we're going to label this. So here's our theta. And so we're going to label this the opposite, hypotenuse, and adjacent sides. I know I'm dealing with the hypotenuse. We're given that one, and we're given the adjacent. So if I look at TOA, I know hypotenuse and adjacent are both in the k. That tells me that the cosine of theta equals the adjacent over hypotenuse side, right? We know how to set up that equation. So we're going to say the cosine of the theta that we're looking for is adjacent, which is 6, over hypotenuse, which is 11. So now that I know I want to solve for theta, I'm going to take the inverse cosine of both sides. That will cancel this out. We get theta equals the inverse cosine of 6 over 11. And if you plug that in to your calculator, we get inverse cosine 6 over 11, and we get this is approximately 56.9 degrees. Okay, you guys, that's it. I'll see you back in class.